All right, welcome to AMOS once more. We are now into agile software development practices. It has two parts. Initially, in this first slide deck, we'll talk about software developer communication and coordination. And in the second part, we will be talking about agile programming, coding practices. We will also later discuss continuous delivery. All right, here we are. In agile software development, the software development team as a whole plays a particularly important role in that it actually has much more responsibility and decision-making power than in traditional software development. So the team as a whole, involving every single team member, software developer, has the responsibility for delivering well-working software in accordance with the agile practices, always working, good for communication, ultimately, of course, also quality assured. There are no traditional engineering managers in Agile any longer. As you can see here, the mapping of these traditional roles of engineering manager, software developer, and quality assurance engineer or software tester, they are all mapped or rolled into one, which is the Agile software developer. And again, the Agile software developer is not working so much as an individual as they are viewed as a collective, as a team. So all of these responsibilities that we have defined classically, traditionally, the who gets to do what and ideally by when, how is it done and how quickly can we do it, as well as it of good enough quality. All of these things have to be answered and handled by the software developer and the software development team. Software development starts, if you will, or in the process of turning requirements into product features. It really starts after the planning meeting. So in the Scrum planning meeting, everyone's involved, so software developers are involved too. But further on, planning after the Scrum, after the planning meeting, is only the software developer's responsibility, because now in the sprint backlog, there is the functionality that has been agreed upon to be implemented this upcoming sprint. And while you may think that's it, Scrum at least offers you one additional level of refinement, which is that the software developers now go about planning their Scrum, their sprint, and by breaking down any business value focus, user story, feature into tasks. This is now a technical management issue. It's not about the business value. It's about how can we turn this particular product requirement into something that the team can realize. So there's a breakdown of product backlog entry, feature / user story into different tasks that could be done by different people. And you actually might even put work hours to it, because now that you're talking about specific people with the different capabilities, what was size or complexity and feature estimation becomes different person hours depending on the abilities of the involved software developers who pick up tasks. Now, you may remember that to simplify, in the AMOS project, we don't really have that task breakdown. If you want to, you can do it, but we really require that all user stories are so small and ultimately are very close to a single task for implementation that this distinction is not something we require of you to do. Still, if you want to, you can try practicing it, and it certainly is relevant in industry. In industry now, you might see something like a task board. Here I'm actually showing you a Kanban board, which is very similar. The idea is that you have your sprint backlog and the features you agreed upon for that upcoming sprint. And now you break it down into tasks and you move them through the processes of implementation, which are, it's up next. because you might have to do multiple features, so you choose which to work on first. So it's getting ready. In a second step, you declare it by moving it from column left to right. You declare it as being worked upon, so everyone knows you are working on a particular feature. And once it's done, or you consider it done, it is put into the final column of done. So there's a backlog, ready to get going, work in progress, and done column in the simplest form. And that shows everyone on the development team where you are with respect to the features in that current sprint that you're working on, that current sprint backlog. It's called a task board, and it visualizes the progress towards finishing the current sprint. Here is why the definition of done is important. These task boards are very easy, so pick them up if you want to. And you can see how you have your stories or your sprint backlog broken down into tasks, which are then put in process, become work in progress. They are testing, they're in testing mode. And if your feature implementation passes your definition of done, then you can consider it done. Here the joke, of course, is that once you relax your requirements, you're not precise, you're actually cheating, then you will be much quicker because you will so much more work have it almost done. Well, obviously don't do it. There's no point in lying to yourself. So after you decided on how to structure your sprint, lined it all up, broke down features into tasks, got them into, turned them ready into work in progress or eventually done. In a full-time team, you actually need to coordinate how you're doing because there may be conflicts and synergies and dependencies between all these different features. So what you do is you need to reduce the scope. You have something we call day planning, of which the most important practice is simply to have a so-called daily scrum. A daily meeting, typically in the morning, where you synchronize the team, where you, as you are already doing in the sprint retrospective, do a roll call as to what are the current problems. So first of all, what are you going to, okay, so what are your current problems? What are you going to work on today? What do you expect will be the interactions with others? In classic Scrum, it really is this daily stand-up meeting or Scrum. I think they struggle a bit about words. It's stand-up in extreme programming and daily Scrum in Scrum. So it looks like this, and it's a roll call, meaning you stand up because you want the roll call to be fast, so you don't sit down, because if you were to sit down, you would keep on yakking. No, you don't want that. You want it to be fast. Everyone speaks once and that's it. And the Scrum Master takes note of impediments and the developers take note of whose work is overlapping with who and make it one-on-ones in terms of if there are interactions that you need to talk about. So don't discuss problems in the daily Scrum, in the daily stand-up meeting. Just take note of who's working on what problems they might be expecting, and then after the meeting, talk to them about it. So it's really just a synchronization point, and it should involve all the pigs, the product owner, the software developers, and the Scrum Master, and the chicken, the customer, other people involved in the company may listen in but are not allowed to speak. So the questions again to be asked are: what did you do yesterday? What will you be doing today? And what problems do you expect? In AMOS, with student teams which are not full-time on a project because you have other courses, we've replaced the daily Scrum, the daily stand-up meeting, with a stand-up email. And I'm very happy to see most of you doing this properly. It's an important information for everyone else to know how other folks who you may not be seeing right away because you're doing different things during the day, how you are coordinating your work and when you're doing it. All right, on to yet another practice, Collective code ownership. Agile methods suggest or require actually that all code be collectively owned. You may think, this is my code and nobody touch it, please. But Agile methods don't want that. They believe that all code is jointly owned, collectively owned. And so everyone should have full read and write access to the code base. The purpose is to really instill a feeling of overall responsibility. So if you see something go wrong, then you will actually feel it's not somebody else's job, but it's your job as well. So it's a collective overall responsibility, leading you to care, leading you to be careful, not to screw up some work that you in more traditional context might consider somebody else's work, and so there's a problem, it's their problem. No, it would be your problem as well. This is particularly important as you implement a lot of work end-to-end. User stories, functionality, the business value creating functionality is end-to-end. You may go from the user interface through the domain model all the way to the database as one programmer doing all of these things, rather than coordinating a front-end developer, domain model developer, and database developer. For that reason, as you need to have all these capabilities, you also need all that read and write access, and you need to understand it, and you need to feel responsible. So Agile methods is thoroughly feature-oriented as opposed to component-oriented, which is a major struggle sometimes as you engage with open source projects. No, in Agile, you go across all layers, and by extension, you need to be competent to do that, and hence you need to have really good developers, like all of you, of course. But in all earnest, because that is really hard to scale, as we are going to have industry talks on scaling Scrum, you will learn about a few more methods as to how to scale up Scrum. All right, so there's some more basic stuff that relates to communication and coordination, not really that specific to Agile methods, but certainly adopted and used by Agile methods. For one, make sure that your code follows the same programming standards, reads and looks the same. Why is it so important? Well, code is read much more often than it is written. So for every line of code you write, it will be read at least 10 times, if not much more. So investing in making it readable at a minimum by following programming guidelines is truly important. If you have very different programming styles, you will be much less efficient at reading other people's code. So it serves to make things easier, it serves to make bugs more easily recognizable, aids navigation, etc. XKCD, comments on that? You can hold the video if you like and read it, but the story here is that she looks at some self-taught programmers' work, and her language, her verbiage gets ever more excited as to how bad his code is, until he finally gives in and says, okay, I'm going to look at some reasonable coding style and apply it to my work. The coding style, you hopefully looked at that. Here's an example from the Java coding styles. It's very basic. It's how your files should start, how to format your code, how to look at basic things like bracketing and methods, etc. While this all sounds really basic, it's actually the most basic things that will be thoroughly annoying, because it's your day-to-day work, it's your bread and butter work. So if you don't agree on where to put the brackets and you've got different styles, you will be at each other's throats. So don't do that. Stick to one programming guideline. In Java, the dominant paradigm is to have the bracket, opening and closing bracket like this here. And the team needs to agree upon that and follow that. Don't have two styles. and all kinds of things that point to how to avoid basic bugs by simply well-known psychological facts about how to write your code. For example, one statement per line of code. All right, conventions, patterns, all of those, they don't stop with just programming guidelines. In fact, the expert programmer has a lot of them in the head. Here are a couple of examples from how to name or what type of methods a programmer writes. And this is taken from the Advanced Design and Programming, the ADAP class that I teach. And it's really just one aspect. So for example, I'm quite sure you all will be familiar with get methods or getters. So you've heard about this because everyone hears about it when they learn Java. A get method is simply a method that returns a value, an attribute of an object from the logical state of that object, and it should not change the state of the object. It's a query method. It only returns information. It doesn't change an object states. Everyone knows that. But as you become more of an expert programmer, you will learn about many other methods, for example, assertion methods. You can write assert statements, but sometimes that's not enough and you need more complex assertions, so you turn them into a method of their own. These are helper methods, which will throw an exception if the assertion is not met, and otherwise you pass through them silently. So there are lots of these method patterns, method naming conventions that come with it. And really the expert programmer knows a lot of them, going all the way from how to name your fields in a class, how to name your methods, how to implement them, how to name classes, how to name packages, how to structure packages, etc., etc. And there are lots of conventions, and the purpose of convention, of course, is to ease communication and coordination, because experienced developers who go by these established conventions know what to expect by just looking at it, and they don't have to dig deeply all the time to figure out what it does, because they know, based on the naming convention, for example, that it will follow the pattern, which means no surprises. They don't have to look in detail, they just know how it will behave, and that's what over time turns you into an expert programmer, knowing all these patterns. All right, so here's a simple quiz. A file may have many authors. Should the names of these authors be listed in the file's header? TA, please stop the video. All right, we are back. So now then, what's the answer? Well, in Agile methods, the answer is absolutely no. There's collective code ownership. You should not single anyone out. So don't put the name or the names of the people who worked on the code into the file header, because that looks like they are claiming some ownership. And if that looks like they're claiming some ownership, someone new who comes by will feel hindered or will be more cautious to change it. And Agile methods doesn't want that. They want everyone to be comfortable changing everyone's code. How that is possible, of course, we will be discussing under test-driven development and continuous delivery. But for here, it suffices to say Agile methods does not want you to be putting your names down on files. From an administrative perspective, the configuration management system, your version control system already does that job anyway. So then, what you learned early in this class to get you going is the build process and the deployment process. And so I want to spend a few words on that, not on the technology. So you learned all about Docker and microservices and continuous delivery in the early tutorials, but the purpose of having a defined build process. The benefits to those who are actually doing it may be obvious, but it may be important, but I think it's important to understand the motivation behind it. The build process is basically a set of scripts or rules, steering build tool, such that independently of a particular person and independently of a particular person's workstation or development setup, you can reliably create a deliverable product. And so that's what the build process does. It builds the system. And once you have a build process in place with all the scripts, you can move it off of a particular developer's machine, as we have done, move it onto Travis CI and deploy through Docker Hub, etc., etc. It makes sure that once you got it working for the whole team, nothing is left of the specifics of one particular developer. You have a defined standard environment that is now the same across all developers. It is the same within test and production environments, and thereby, as always, no surprises, just automated development and based on the build, testing, and delivery. And so it's quite important. Here is the benefits, respectively, what the developer should be doing. Understand that this is the purpose. Don't change the build process to match only their environment. In conjunction with that, you use it to synchronize in the team repeatedly every time you commit or push your code. And as a consequence, you really need to make sure your code works. So in the most basic case, that means it compiles. The idea that you commit non-compiling code is just really bad. Hilarious, but not hilarious to those who actually catch up with the code repository and run into your non-compiling code. So never ever commit non-compiling code unless exceptional circumstances, of which I really can't think right now. Certainly going home on a Friday night, Friday evening, and committing your unfinished changes for the purposes of making a backup is definitely not a good idea for pushing code to the code repository. In addition, there's much more to be said than just compiling code, must pass all the tests, etc., etc. We'll come back to that later. Here's another cartoon on how things used to be. The development cycle, Friday evening edition. This guy did exactly what I just told you not to do, which is consider the code repository, the version configuration, the version control system to be the place to make a backup of the code rather than to contribute only well-working code. And so here the point is he wants to go home. So he ignores the team and someone else runs into the problems created by this guy who probably committed non-working code, non-compiling code, and is suitably, properly, justifiably so upset about having run into non-working code. You really shouldn't be doing it, not only for the sake of the project, but also for the sake of your team members. It used to be that you would manage all of this by hand. Today, it really should be fully automated through scripts. You do not curate libraries by hand and put them into the code repository any longer. You simply say what libraries you need in the build script, and the build script will pull them automatically from the respective public repositories. Certainly if it's open source software, if it's private, if it's closed source software, your local libraries you purchase, then from your local supplier repository of such libraries in their respective version. Today, you actually still need to maintain the list of libraries you're using by hand. You have a spreadsheet for that in the planning documents. Ideally, in the future, this is also automatically generated because the build system actually knows what libraries you're pulling in, and because otherwise it wouldn't be able to build. So you specify in there what you're using, and that should actually be used to create the final bill of materials as you might deliver it to a customer. So here's another quiz. Last week, you delivered your product release to a client. The phone rings and an angry client is on the line complaining about something going wrong. Well, what could possibly have gone wrong? Spin some interesting thoughts, please. TA. All right, back again. I hope you pressed the button quickly enough, TA. If not, you do it just now. Well, so the development team of the client doesn't like it. What could have gone wrong? Well, I don't know. Maybe you didn't follow the promises of certain APIs. Your API isn't delivering what they were looking for. Maybe it's just really buggy code. So the quality assurance team of the client might look at it, might find it not testable, or might find existing tests to not be suitable or not provide enough test coverage, etc. Or the client's legal team looked at it, looked at the bill of materials and found, oh, there's an open source library licensed under AGPL, and we absolutely do not want that. So the client legal team stopped the client project dead in its track because you can't use that software. So the answer here is all of the above could have gone wrong. Thank you very much for this session, and we will continue in a bit with the next slide deck. Thank you.